Welcome to this channel, and in this video I'm going to be continuing the Cambrige IGCSE Paper 2 extended video question 11 to 20 that we're going to be taking in this video. Okay, so question 11 says two shapes are mathematically similar, find the value of h, right? So when you're in this kind of condition, all you simply need to do is to compare the sides of the shape, right? So over here you can see that the height of this is 6.3, and then we don't know the height here, and then we know that the base here is 9, the base here is 5, so we can simply compare. So we could simply say 6.3 all over the h, right, is equal to, that's we're comparing the height of this to the height of this, and then follow that same pattern, and that's going to be equal to 9, that's for the larger, divided by 5 of the smaller, right? This to this, this to this, right? So then our goal is to get value of h. So then we multiply it through, and that's going to be 5 times 6.3 is equal to 9h. So 5 times 6.3, we're going to have 6.3 times 5, and then with that we're going to have 31.5, right? So let's calculate that. 6.3 times 5, that's 31.5 equals 9h, and then dividing through by 9, 31.5 divided by 9 is 3.5. So h is 3.5 cm. So this is kind of like a length scale factor, right? You're similar, so the ratios of their sides are also equal. And please ensure that when you're doing the comparison, you follow the other, right? So 6.3 over h. So do not make the mistake of saying 6.3 over h is equal to 5 over 9. If you started off with 6.3 to h, you must start again with the larger. Or if you wanted to start from the smaller, what you're going to have is h over 6.3 is equal to 5 over 9, because you're starting with this and then you're going to start with it again. So h is 3.5. So next question says area of the smaller shape is 16 cm squared. Calculate the area of the larger shape. So now this leads us to what we call the area scale factor, and this is very crucial, not hard in any way, right? So we're going to do something here. We're going to say we're looking for the area of the larger shape, right? So we could call the area of the larger shape AL and call the area of the smaller shape AS. So that is always proportional, equal to what? The square of the length scale factors. And what's the length scale factors? This stuff over here. 9 over 5 equal to 6.3 over h. Right, so since 6.3 over h is equal to 9 over 5, what we're going to have over here is that it's going to be proportional to the square of this length scale factors. So in the case of 9 over 5, we're going to have 9 over 5 all squared. And you can see I use 9 over 5 because look at what we have at the numerator. AL, area of the large shape over area of the small shape. And when we were looking at 9 over 5, what was happening here? We were looking at the base of the larger divided by the base of the smaller. So that corresponds to AL, which has to do with the larger, 9 which has to do with the larger, AL has to do with the larger, AS smaller, 5 has to do with the small. Do you get that? So if you ended up with 5 over 9, that's going to be wrong, right? Because it has to correspond. Do you get that? So AL over AS will be equal to 9 squared is 81, then 5 squared is 25, right? And then we've been given that the area of the smaller shape is 16, so AS is 16. So AL over 16 is equal to 81 over 25. So then we multiply through by 16. So AL is going to be equal to 81 over 25 multiplied by 16. So if we should simplify, 81 divided by 25 times 16, that's going to be equal to 51.84. 51.84 cm squared, right? That's the area of the larger shape. So another possible thing you could have done here is, since we said AL equals AS, and then remember that what we had here was what, 9 over 5, right? And then what we had here is 6.3 over H, and we later got the value of H as 3.5. So what we have is that 6.3 over 3.5 is equal to 9 over 5. So you still have the right to say AL over AS is equal to 6.3 over 3.5, which is same as 9 over 5, right? That's it. So 51.84. Question 12 says the diagram shows the speed time graph for 16 seconds of a car journey. Find the deceleration of the car in the final 4 seconds. In the final 4 seconds. So the car started off with a speed of 10 meters per second, kept going, right? Kept going, and then at some point he began to decelerate. It's important to know that deceleration is the opposite of acceleration. Acceleration means that speed is increasing as time goes on, but deceleration means that speed is decreasing. You can see the decrease. It fell from this point. It was 10 meters per second. It has now dropped to the ground. It has now dropped to this point where speed is 0. Do you get that? And how do we calculate this stuff? It's simply change in speed over change in time, right? Change in speed divided by change in time. So what's the initial speed? Started off with 10, ended up with 10, with 0. So you can simply say 10 negative 0 divided by how long did it take? The change in time from 12 seconds to 16 seconds. That's what he took to come from 10 to what? 0. So that's going to be 4. So 10 divided by 4 is equal to 2.5. And that's 2.5 meters per second squared. And how could you simply remember this? First of all, I've told you that it's the opposite of acceleration. And if you study, you know that acceleration is equal to velocity over time, speed over time, right? So what happens here is, we know that the unit of speed is meters per second, right? The unit of time is seconds, right? So meter per second divided by second, we're going to have a meter per second square. You get that? So that should always remind you. That should give you an idea. That's simply the slope of this graph in this region, right? Because that's the change in the speed divided by the time taken, right? The change in the speed, we could call that v. Let's call that v, and then divided by the time taken. That's going to give us the deceleration. Okay, B says find the total distance traveled during the 16 seconds, right? So it's important you know this formula that says that speed is equal to distance over time. So to get distance, we simply multiply through by time. So distance is equal to speed times time. So that's literally a form of area. So anytime you're given a speed time graph and you're asked to get the distance traveled in the entire motion, it's simply the area under the graph. Let me clean this off so that you have a clearer picture. Okay. Let me clean this off. So we're going to get the area. You can see two shapes here. Total, we could call it a trapezium, but if we want to break it down, this is a rectangle, right? This is a rectangle, right? And then this is a right angle triangle, right? So we could then get the area of this rectangle. So area of rectangle is going to be what? The area of the rectangle is simply the length times the breadth. And what's the length? The length is this, 12, right? And the breadth is what? Or the width is 10, because it took from 0 to 10, right? And then the width is 12. So 10 times 12 is equal to 10 times 12, which is equivalent to 120, right? And then we have the right angle triangle, and that's going to be area of the right angle triangle, right? And for it to be right angle, that means the angle here is 90 degrees. And what's the area of a triangle? That's simply half times base times height sine theta, right? But since theta is 90 degrees, sine 90 is 1, right? So it's simply half base times height. So the area of the right angle triangle is equal to half multiplied by the base of the triangle. The base of the triangle, what's the distance? That's 4. And then the height is 10. So 1 over 2 times 4 times 10. So 2 goes to itself 1, 2 goes to 4, 2. 2 times 10, 20. So that's going to be 120 plus 20, and that's 140 meters, right? So that's the total distance. So anytime I give it a speed time graph, the area under the graph is the distance covered, right? Question 13 says 3 to the 3p times 3 to the 2p is equal to 729. So that leads us to some important laws, right? If you have x to the a multiplying x to the b, you can see that we have x is going to be equal to x to the a plus b. So let's apply that here. We have 3 to the 3p times 3 to the 2p. So what's it going to be? 3 to the 3p plus 2p. And that's equal to 3 to the 5p. So that implies that 3 to the 5p is equal to 729. So the next thing to do is to see or to think of a way to express 729 as a power of 3. And then if you look at the powers of 3, 3 to the 1 is 3, 3 to the 2 is 9, 3 to the 3rd is 27, 3 to the 4th is 81, 3 to the 5th is 243, 3 to the 6th is 729. Right? Normally in these examinations, they will make the values too far apart, so you could easily guess where it's coming from. So if you get the value of 3 to the 6th is going to be equal to 729, right? So we can simply then say that 3 to the 5p is equal to 3 to the 6th, because we're trying to achieve equal base. That leads me to this law where we're talking about equality of bases that says that we have x to the a equal x to the b. That implies that a is equal to b. If x to the a is equal to x to the b, then a is b. So if 3 to the 5b is equal to 3 to the p, then what happens? 5b is equal to 6. So we divide through by 5, right? So 6 divided by 5 is 6 divided by 5. The closest whole number is 1. 5 times 1 is 5. 5 times 2 is 10. So that has passed 6. So 5 times 1 is 5. We need an extra 1 to make it 6. And then divide it by 5. So that's 1 whole 1 over 5. So p is equal to 1 whole 1 over 5 or 1.2. Any of those. That's when we convert to decimal. B part says 32x to the 10 and then all into up to, that's 1 over 5. So what's that going to be? So you have 32x then to the 1/5. So that leads me to this law. I hope you're jotting down. That says that a to the x to the y is equal to a to the xy, right? And also write this down. If we have 2 parts or maybe 3 parts, could be multiple parts, pq to the n, it's simply p to the n times q to the n. So 32x then to the 1/5 is equivalent to 32 to 1/5 multiplied by 310 x then 1/5, right? So what is 32 to 1 over 5? That leads to this law, right? That says that a to the n over n is equal to the nth root of a raised to m. So what's the nth root? So in this case, what's our n? 5. So we're going to get the 5th root of 32. And what is n? 1. It's 1 over 5, right? And then raise it to 1. And that's not going to do much, right? So multiplied by x to the 10 to the 1/5. And then we're then going to use this law over here that says that a to the x multiplied by y to the power y, is equal to a to the xy. So x to the 10 to the 1/5 is equal to x to the 10 times 1 over 5. And that's When 5 goes to itself, 1. 10 divided 5, that's 2. So that's x squared. So what's the fifth root of 32? That's simply the number that's going to multiply itself 5 times, right, to give 32. And that's simply 2. 2 times 2 times 2 times 2 times 2 is going to give us 32, right? That's 2 into 5 places. So that's 2 times x squared, which is 2x squared. So that's the simplification, 2x squared. Question 14 says, y equals 2w squared negative x. Rearrange the formula to make w the subject. So this is simple. Anytime we're asked to make a variable the subject of the formula, all we simply need to do is to isolate, right? Anything that doesn't have that, just shift it aside. Now you can see the formula given, that's y equals to 2w squared negative x. So you don't want any stuff that doesn't have w. So how do you eliminate x? So we have y equals 2w squared negative x. So we can simply add x to both sides to eliminate x, right? And then we add x over here. Don't forget that. So this goes, and then we have that y plus x is equal to 2w squared. And then we could then divide through by 2. So that shows that y plus x over 2 is equal to w squared. And then that means we could say that w squared is equal to y plus x over 2, right? So what does the question say? Make w the subject and say w squared. So in order to get the value of w, all we simply need to do is to get the square root of both sides, right? And before we continue, it's important to note that when you're solving square, like for example, if you're solving x squared equals 4, right? The solution is going to be x equal to plus or negative square root of 4, right? If I write it out as square root of x squared, right? So we're getting the square root of both sides, but we're going to have a plus or negative, because if we have x squared equals to 4, you're not just going to say 2, right? Because negative 2 plus or negative 2. Negative 2 times negative 2 is 4. So what we're going to have is the square root of w squared is equal to plus or negative square root of y plus x over 2. Because it could be positive, it would give up, right? Just like in this case, when negative 2 was squared, it gave 4. When 2 was squared, it still gave 4. So the square root of w squared is going to be w, right? So w is equal to plus or negative y plus x over 2, right? That's it. Question 15 says, on the Venn diagram, shade the region P union Q complement, right? Now this is easy to do. Q complement implies not in Q. That means we have a larger set, the universal set, right? And then we're looking at the elements that are not in Q, that are in the universal set. So what happens here? We're going to leave Q out and then shade every single outer region, because it's P. This is P. We're shading P, right? And then union Q prime or Q complement. So every other thing apart from Q that is in the universal set. So we shade every single part of leaving the Q region, which is over here. So that's what we have. You get that? That's it. So that's P union Q prime. P union elements that are not in Q that are in the universal set. Right. Okay, next question says B n of the universal set equals 20. N of A union B all prime is equal to 1. N of A is 12 and N of B is 10. Complete the Venn diagram. Right, so you should understand that the whole of this, which is A, B, this whole region represents A union B. So if the number of elements in A union B complement is 1, remember that the total number of elements, which is the universal set is 20. So to get the number of elements in A union B, we're going to have 20 negative 1. And 20 negative 1 is 19. So N A union B all prime is equal to 1. We're going to place it over here because, right, it's exempted. Because this is A union B. And then every other part out is A union B prime. Right? Okay. Excuse me. So what we're then going to have in totality over here is 19. Now, that's why you should then know this property that says that N of A union B is equal to N of A plus N of B negative N A intersect B. So N of A union B, this is very clear, is simply N of A plus N of B minus those that are both in A and B, because we don't have to start counting them again, right? It has already been counted in respective zones, right? So N of A union B, which we've calculated to be 19, remember when it was calculated? So over here 19 is going to be equal to N of A, which is given to us in the question as 12, and N of B, which is given to us as 10, and then negative N of A intersect B. So let's call that X. So X is going to be 12 plus 10 is 22. And then this crosses, and that's 22 negative 19, and that's 3. So that is the value of NA intersect B. And that's what we're going to place over here. Right? So NA is 12. And you know that this is the whole of A. This is the whole of A. And the whole of A is 12. So since we have 3 over here, so make up to the 12, which is NA, we need 9. 9 plus 3, 12. That's all in A. Now for B, this is the whole of B. Sharing boundaries, right? This is the whole of B. We already have 3 in here. In total, we have 10. How many more do we need? 7. To make it 3 plus 7, 10. You see that when you add everything together, 9 plus 3, 12. 12 plus 7, 19. 19 plus the one out, which is A union B complement. That is that which is not a union B. Then plus 1. 19 plus 1, we have 20. Right? That's it. Question 16 says, find the lowest common multiple of 12x to the 8 and 8x to the 12th. And this is very simple. We could make it easy for yourself. You could take the whole parts and then take the algebraic parts. So we have 12 and we have 8. So we could simply get the LCM of that and then get the LCM of x8 and x12. So looking at 12 and 8. So if we get the LCM of this, the lowest number here that could go 2. So 12 divided 2 is 6. 8 divided 2 is 4. 2 could still go, right? So 6 divided 2, 3. 4 divided 2 is 2. So 2 could go. But since 3 can divide 2 perfectly, we bring down 3, and 2 divided 2, we have 1. So we could bring up 3. So 3 could go here. So that's going to be 3 divided 3, that's 1. So since 1 can divide us perfectly, we bring down 1. Everything is done. So we're then going to have 2 times 2 times 2 times 3. And 2 times 2 times 2 times 3. 2 times 2 times 2 is 8. 8 times 3 is 24. And then if we then get the LCM of x8 and x12, what's that going to be? The lowest number that could go here is x8, right? So x8 divided x8 is 1, right? And then x12 divided by x8 is what? Right? Remember the law of indices that says that x to the a divided by x to the b is equal to x to the a negative b. So x to the 12 divided by x to the 8 is, we're going to have x to the 12 divided by x to the 8, which is equal to x to the 12 negative 8. And that's x to the 4. And then we write that down. So x to the 4 could go again. So since 1 can divide this perfectly, we bring down 1. Then x4 divided x4 is going to be what? x4 divided by x4 is going to cancel out. We're going to have 1. So x8 times x4, using the multiplication law, remember, xa times x4 is going to be equal to x to the a plus 4, which is x12. So 24, which we got over here, that's going to be 24 times x to the 12, and the LCM is going to be 24x to the 12. So that's it. Question 17 says, ABC are points on the circle, center O. Angle OBA is 28 degrees. Find angle ACB. So that's simple. So you can see that this is the center of the circle, and then the radius is simply the distance between the center of the circle and any point on the circumference. So this is a radius, this is a radius, and this is then therefore going to form an isosceles triangle where the two base angles are going to be equal. So if here is 28, here is also going to be 28. And then to get the value of this, remember that angles in a triangle sum to 180 degrees. So that's going to be 180 negative 28 plus 28. And that's going to be 180 negative 56, right? And 180 negative 56 is 124. So the angle over here is 124. Then you should then remember the property that says that the angle at the center is twice the angle at the circumference. That's when they lie on the same arc, right? So this is the arc that subtends angle OAB, AOB, and then ACB also has this arc. So if here's 124, angle at center, which is 124, is twice the angle at the circumference, which is the angle over here, which is asking the question, ACB. So 2 multiplied by ACB. So in order to get a value of ACB, we divide through by 2, and that implies that ACB is going to be equal to 62 degrees. Now you also do well to include the reasons in bracket, right? The geometric reasons. In this case, you would say angle at center twice, right? You could give a reason to that. And then as for every step you take to get angle AOB, you have 180 negative 28 plus 28. What's going to be your reason? Angles in a triangle, right? You get 124. And then the next step you take is dividing 124 by 2. And what's the reason? The angle at the center is twice the angle at the circumference. Okay, B part says P, Q, and R are points on a circle. TU is a tangent to the circle at P. Angle TPR is equal to 47 degrees, and angle PRQ equals 52 degrees. Find angle RPQ. So we have to apply some circle theorems here. So the second theorem you can simply apply here is the fact that alternate segments are equal. So this is a segment and this is a segment. Alternate segments, right? So here is 47, here is also going to be 47. It's alternated. This segment is alternating with this segment. And the same applies here. If here is 52, here is also 52. So as here is 52, it alternated this other segment, right? This is the alternate segment, so they have the same angle, right? I'm going to show that now. But let's get RPQ. So this is RPQ. So let's call it X. So what we're going to have is X. This is a triangle, right? So the sum of angles in the triangle equals 180, right? That's X plus 52 plus 47 is equal to 180. And then 52 plus 47 is 99 equals 180. Then X is equal to 180 negative 99. And 180 negative 99 is 81 degrees. So that tells us that RPQ is 81 degrees. Or what you could have done, you can take this, and let's say this is the center, right? And then let's take this down. Our goal is to get here. So remember that from the center to the tangent, what the angle going to form, that's going to form is 90 degrees. If here's 47, here's going to be 90 negative 47, which is 43. And this is radius, so this is isosceles. So if here's 43, here is also 43. And then to get here, 180 negative 43 plus 180 negative bracket of 43 plus 43 is going to give us 94, right? And then using the fact that the angle at the center is twice the angle at the circumference, 94 divided by 2 is 47, right? And then we've got in here as 47, and then angles in the triangle sum. So you see why it's easy just to know the theorem. I want to give you the basic ideas and everything behind it, right? Okay, question 18 says, the solid cylinder has radius 5 cm and height 8 cm. Calculate the total surface area of the cylinder. So, now this is a cylinder. And the one you should know about the cylinder is that it has two circular discs. And what's the area of the circle? Pi r squared. What's the area of the circle? Pi r squared. Total surface area, right? On all surfaces, what's the area they take? Now you can see that the cylinder also has another part, which is the body around it, right? And then you could actually take the length of this, which is the distance around the circle. And what's the distance around the circle? That's the circumference. And the circumference of a circle is equal to 2 pi r, alright? And then you have the height of the cylinder, which is here as h. So if we should unfold the cylinder, it comes out this way, right? Such that if we start folding, we're gonna have this. So the length of this, which is the length of this, that's the circumference of the circle, is 2 pi r. Right? Sorry, excuse me. And then this is h. So h, this is kind of like a rectangle, and h times 2 pi r is 2 pi r h. So the total surface area is going to be pi r squared plus pi r squared plus 2 pi r h. We're getting the total area. Pi r squared, then the body, right? Which, if we now break out and open up, is now going to be h times that length, which is 2 pi r h. So pi r squared plus pi r squared is 2 pi r squared plus 2 pi r h. And then we could factor out 2 pi r, and that's going to be 2 pi r into r plus h. Then simply substitute what's given. I just did it so that you understand the reason behind everything, right? Not if it's in the exam, all you simply need to do is to write down the formula and substitute, right? Which is 2 pi r squared plus 2 pi r h. So 2 pi r, the radius is 5, so we have 2 pi multiplied by 5 into the radius, which is 5, plus the height, which is 8. So 2 pi times 5 is going to be 10 pi, and then 5 plus 8 is 13. So 13 times 10 pi is 130 pi. And then if we should write it out fully, 130 multiplied by pi is equivalent to 408.407 cm squared. This is also a good answer. This is a good answer. And that's that. Okay, question 19 says, find the nth term of each sequence. Now you have 11, 8, 5, 2, negative 1, it keeps going, and then let's start with that. So you can see that there's a constant difference of negative 3. Negative 3 is constantly subtracted. 11 negative 3, 8. 8 negative 3, 5. And that rings a bell to what we have as the arithmetic sequence, or the arithmetic series, arithmetic sequence. Right, because there's a constant difference, there's a constant addition, the constant deduction of negative 3. So, knowing that the nth term of an arithmetic sequence is equal to a plus n negative 1d, what's the a? A represents the first term of the sequence, and that's 11, right? So 11 plus, we're asked for the nth term, so we don't need to substitute any value for n. And then the d is the constant difference that is being added, which is negative 3. 11 is added to negative 3, right? 11 plus negative 3, positive negative is negative, right? And then d is what? Negative 3. So that's going to be 11 plus n negative 1 into negative 3. And then we could then write it out as 11 plus negative 3 into n negative 1, right? So positive negative is negative. So that's 11 negative 3 and negative 1. That's going to be 11 negative 3 times n, negative 3n. Negative 3 times negative 1 is plus 3. So 11 plus 3 is 14, negative 3n. So that's 14, negative 3n. And that is the end term of the sequence. So the second sequence, you can notice something here. There's a constant multiplication. There's a constant ratio. 5. 1 times 5, 5. 5 times 5, 25. 25 times 5, 1. You see that? And that leads us to what we have as the geometric sequence, right? The geometric sequence. And what's the nth term of a geometric sequence? Simply AR to the n negative 1. So what's A here? The first term, which is 1, multiplied by what's R? That's the constant ratio, the constant multiplier, which is 5. And then to the n negative 1, because we're looking for the nth term. So we don't have to substitute any value for n. So 5 to the n negative 1 is the nth term. So if maybe we're looking for the third term, we substitute 3 into this. 3 negative 1 is 2, right? So 5 squared is 25. And that's the third term here. So that's it. Okay, last question. The area of a rectangle is 55.2 cm squared, correct to 1 dp. The length of the rectangle is 9 cm, correct to the nearest cm. Calculate the upper bound of the width of the rectangle, right? So all you're simply going to do here, you have to first of all recognize that the area of a rectangle is equal to the length multiplied by its width. So it says calculate the upper bound of the width. So the width is going to be equal to the area divided by the length. But we have to be very careful here. We are doing our best to maximize the width. As it says, the upper bound, which is the maximum threshold, right? The width cannot go beyond that value. It cannot even get to that value. So the question now is, what is the upper bound of the area? The question says 55.2 cm squared, correct to 1 decimal place. So it was corrected to 1 decimal place. So there was a number before it, right? So what we simply do here, we then get the upper bound of the area, and that's going to be 55.2. And then since it was corrected to 1 decimal place, what's 1 decimal place? Smallest unit 0.1. So what you do is to divide this by 2. 0.1 divided 2 is 0.05. Do you get that? So that's 0.05. Then we add that to this. That's going to be the upper bound. If it was the lower bound, it's going to be 55.2 negative 0.05. Right? Because we have a value here, and then it can go beyond this, because 55.2 plus 0.05 is 55.25. And if we should correct 55.25 to 1 decimal place, what we're going to have is 55.3. So this just gives us a threshold, because before 55.25 we have 55.24, which would actually round that out. So this is the maximum threshold. So the upper bound of the area is 55.25. But we will then get the lower bound of the length. Why? Because let's say we're dividing two numbers. 10 divided 2 is going to give you what? 5. And then if you should say 10 divided 1, it's going to give you 10. So you can see that as the denominator increases, excuse me, as the denominator increases, the output decreases. And we're looking at the upper bound of the width. We want to maximize. We're looking at the highest possible value. So we're going to look at the lower bound. So it says the length of the rectangle is 9 cm, correct to the nearest cm. So that is 1 cm. So the nearest 1 cm, the nearest cm. So if we divide 1 cm by 2, that's 0.5. So to get the lower bound, what we're going to have is 9 negative 0.5. 9 negative 0.5. If it was the upper bound, it's going to be 9 plus 0.5, which is going to minimize the width, because it's increasing the denominator. So 9 negative 0.5 is 8.5, and 55.25 divided by 8.5 is going to be 6.5, and that is the upper bound of the width. Thank you so much for watching this video. Right, in the next video we're going to be taking questions 21 down to the last question. Please do expect that you watched the remaining part. Thank you so much for watching this video to this point. Do you also like this video, share, comment, subscribe to this channel if you haven't. Thank you. Have a nice day.